Right now, literally hundreds of miles above your head, a silent war is already being fought.
Yeah, and fought at thousands of miles an hour, actually.
Exactly. And it's completely invisible to the naked eye. But, I mean, if the wrong satellite gets turned off today...
Oh, the global economy grinds to an absolute halt tomorrow.
Right. We're talking about a domain where ships don't sail on water, but they glide through this freezing void.
And the terrain isn't made of, mountains and valleys. It's made of gravitational pulls and orbital trajectories.
Which is just wild to think about.
Yeah.
Welcome to this deep dive, everyone. Today, we're taking a shortcut to making you a well-informed master of space operations.
That's the goal.
To do that, we are pulling our insights from two foundational documents. First, the United States Army Space Reference Text, and second, Joint Publication 314, Joint Space Operations.
Yeah, and together, these two sources really form the absolute bedrock of understanding how the military operates in, from, and to space.
Our mission today is to pull back the curtain on the origins of national participation in space. We're going to explore the laws and policies that govern the cosmos and really break down the joint military doctrine that treats space not just as a laboratory for science experiments, but as a critical, contested warfighting domain.
Because honestly, space isn't just a science fiction battlefield anymore. It's the invisible backbone of modern life.
It really is. It affects literally everything, like the map application on your phone, global financial transactions, all the way up to early warning systems for missile defense.
Right. But before we get into military strategy or, how to actually fly a satellite, we have to figure out who actually makes the rules up there.
Okay, let's unpack this. Because the foundational guardrails come from the 1967 Outer Space Treaty, right?
Correct. It was developed through the United Nations, and currently 140 entities are involved with it.
Wow, 140.
Yeah, it's massive. The treaty lays down some really sweeping ground rules for how humanity is supposed to interact with the void.
I look at the Outer Space Treaty a lot like international maritime law. Like, if you're out in international waters on Earth, no single country actually owns the ocean.
Right. You can't just claim it.
Exactly. You can't draw a line in the water and say, this is my sovereign territory. But the ships sailing on that ocean, they remain the sovereign property of the nations whose flags they fly. And it seems like space works under a very similar premise.
That maritime parallel is incredibly useful for understanding this. The Outer Space Treaty explicitly states that space is free for use by all countries.
Okay.
No nation can claim sovereignty over outer space or celestial bodies like the moon. You can't just, plant a flag in a lunar crater and declare it the 51st state.
As much as some people might want to.
Right. And the treaty also explicitly prohibits placing nuclear weapons or other weapons of mass destruction in orbit or on any celestial bodies.
That feels like a pretty important rule.
Yeah.
But the treaty also uses this phrase, peaceful purposes, regarding how space should be utilized.
It does.
But looking at the massive military budgets dedicated to space today, I have to imagine that phrase gets stretched pretty thin.
Oh, it's one of the most highly debated phrases in all of international law.
Yeah.
The United States has historically interpreted peaceful purposes to mean non-aggressive acts.
Non-aggressive.
Exactly. So the United States' position is that non-aggressive military use of space, things like surveillance, reconnaissance, military communications, that is all perfectly legal.
But I'm guessing not everyone agreed with that right away.
Well, during the Cold War, the Soviet Union initially argued that peaceful meant strictly non-military, like zero military presence.
Interesting.
But over time, the standard that allows for defensive and informational military activities has just become the accepted norm globally.
Okay, so we have rules against claiming the moon and rules against orbital nukes. But what happens if something just breaks?
What do you mean?
Say a satellite falls out of orbit and crashes into a neighborhood on Earth. Who actually pays for that?
Believe it or not, the international community foresaw that exact problem. Yeah, it's covered by the 1972 Liability Convention and the 1975 Registration Convention.
Okay, how does that work?
The mechanism is pretty straightforward, actually. States must register whatever they launch into orbit, and the launching state is ultimately held liable for any damage its space objects cause.
Oh, wow.
So if your registered satellite falls out of the sky and flattens a house in another country, your government is on the hook for that damage, legally and financially.
That is wild. Okay, so that covers the sweeping international treaties. But the sources also dive into domestic space law.
They do, yeah.
And they bring up this genuinely incredible anecdote from 1986 to explain how domestic law gets written.
Oh, the Captain Midnight incident.
Yes. So there's this United States citizen named John R. McDougal, and he was frustrated with the premium cable network home box office because they started scrambling their satellite signal.
Right, and charging extra fees for it.
Exactly. So McDougal actually built his own uplink equipment, hijacked the satellite signal, and broadcasted a protest message about his cable bill directly over the network's movie broadcast.
Calling himself Captain Midnight.
Yes. Which honestly sounds like a completely harmless, almost funny prank.
It does sound funny, but it fundamentally changed federal law.
Because the government freaked out, right?
Terrified them. National security officials were looking at this like, if a disgruntled guy in his backyard can build a rig to hijack a commercial satellite just to complain about cable fees.
Oh, I see where this is going.
Right. The immediate question became, what could a sophisticated adversary do to a critical military communications network?
That is terrifying, actually.
It really is. That single incident directly prompted the 1986 interference with the operation of a satellite law. It made it a federal crime to maliciously interfere with satellite transmissions, bringing severe penalties to what had previously been kind of a legal gray area.
It's amazing how an argument over a cable bill accidentally built the foundation for domestic space security.
History is funny that way.
It really is. But if space law dictates what nations cannot do, space policy dictates what a nation actually aims to do.
Yeah.
Looking at the history in these sources, I have to imagine the United States' posture shifted pretty dramatically once the Cold War really ramped up.
Oh, it was a massive evolution. What's fascinating here is if we go back to the 1958 National Aeronautics and Space Act, the mandate was strictly to separate civilian and military space programs.
They wanted to keep them completely, totally apart.
Exactly. The focus was heavily skewed toward peaceful exploration. So the civilian side went on to run the Apollo program, land humans on the moon, while the military side just quietly focused on securing the nation.
But the military realized pretty quickly that space wasn't just a side project, didn't they?
Yeah, the critical pivot happened during the Carter administration with Presidential Directive 37.
Okay, what did that do?
Well, the national security establishment looked at the board and realized their entire framework for survival relied on space systems.
You mean like early warning systems?
Precisely. Early warning systems to detect Soviet missile launches. This directive marked the moment the military officially began viewing space not just as a support function for troops on the ground, but as a potential warfighting medium in its own right.
Which brings us to the modern era. The current Department of War space policy, specifically, Directive 3100.10, explicitly recognizes space as a priority domain of national military power.
It's a huge shift from 1958.
Absolutely, and the sources make a really interesting historical comparison here to the Key West Agreement of 1948. Back then, after World War II, the military had to figure out how to divide up airplanes among the Army, the Navy, and the newly formed Air Force.
Right.
Today, they're using those exact same principles to figure out who gets to do what in the space domain.
The parallel is very intentional. Just as the Army needs its own helicopters for close air support despite the existence of the Air Force, different branches of the military need access to their own space-enabled assets, even with the existence of the United States Space Force. Every branch relies on the domain differently.
I do want to push back on one thing, though.
Yeah, sure.
This whole idea of cleanly separating the civilian and military sectors, it feels like a relic of the 1950s. Today, those lines are completely blurred.
You're not wrong.
Right. You have private commercial companies launching highly classified military payloads on their rockets. You have commercial internet satellite constellations being actively used by soldiers on the ground in modern conflicts like we've seen in Ukraine. The military is fully relying on commercial civilian infrastructure to fight wars.
And the current policy frameworks are being forced to adapt to that exact reality. Commercial integration isn't a luxury or like a backup plan anymore. It's a fundamental necessity for national security.
Because the military can't keep up.
Exactly. The military simply cannot afford to build or replace systems as fast as the commercial sector can.
Okay, so we've established the laws and we've mapped out the policy.
Yeah.
But none of that matters if you don't understand the physical environment where all this takes place.
The geography of the invisible battlefield.
Exactly.
Yeah.
Let's talk about the physics. Our sources define the space domain formally as the area equal to or greater than 100 kilometers above mean sea level.
Which is about 54 nautical miles up.
Right. It's the precise altitude where atmospheric effects practically vanish, aerodynamic flight becomes completely impossible, and orbital mechanics take over.
And operating in that zero-gravity environment requires what doctrine calls space systems. But a space system is not just the metal box floating in orbit.
Here's where it gets really interesting. Think of a satellite system like a deep-sea diver.
Okay, I like this.
If you have a diver working at the bottom of the ocean, you actually have three connected parts making that dive possible.
Right.
You have the diver in the suit under the water, you have the support boat floating on the surface, and connecting them, you have the vital air hose. A space system is broken down the exact same way.
Taking that analogy, the diver is what doctrine calls the orbital segment. That's the actual spacecraft flying in the vacuum of space, carrying the cameras, the sensors, or the communication relays.
Right. And the boat on the surface is the terrestrial segment.
Exactly. These are the ground stations, the launch facilities, the massive radar antennas, and the military personnel operating them down here on Earth.
And finally, you have the air hose. That's the link segment. This is the invisible connection, the electromagnetic spectrum connecting the orbital and terrestrial segments via uplinks, downlinks, and crosslinks.
It's the constant stream of data traveling back and forth.
Now, this diver analogy is crucial because it explains exactly how space warfare actually works. If you want to stop a deep-sea diver, you don't have to put on a suit, dive to the bottom of the ocean, and fight them hand-to-hand in the dark.
No, that would be incredibly difficult and expensive.
Right. It's much easier to just cut the air hose or take over the boat. In space terms, attacking a space system doesn't necessarily mean launching an expensive missile to blow up a satellite in orbit.
Right. You can just sever the link segment with electronic jamming or launch a cyber attack against the terrestrial segment on the ground, which is why the vast majority of interference in space operations targets the link and terrestrial segments.
It's just easier.
It's way cheaper than launching a missile. It's often reversible, meaning it doesn't create permanent space debris, and it's infinitely harder to trace back to a specific attacker.
That makes total sense. So let's talk about where these divers are actually swimming, because orbital mechanics dictate everything about how a satellite is used.
Absolutely.
The sources break down different types of orbits. First, you have low Earth orbit. This is relatively close to the planet.
Very close. And satellites here are moving incredibly fast, whipping around the entire globe in about 90 minutes.
Right, but because they're so close to the surface, they have a very narrow field of view.
Yeah, it's like looking through a straw.
Exactly. So to get continuous global coverage from low Earth orbit, you need massive swarms, sometimes thousands of satellites passing information to each other like a bucket brigade.
Conversely, if you push a satellite much further out, you reach geosynchronous Earth orbit, which is roughly 35,786 kilometers up.
Which is way out there.
It is. But at this precise altitude, physics does something highly advantageous. The satellite's orbital speed perfectly matches the rotation of the Earth.
Oh, wow.
Yeah, so to an observer standing on the ground, the satellite appears to be parked in one fixed spot in the sky.
That is so convenient.
Because it's so high up, a single satellite in this orbit can see a massive footprint of the Earth's surface constantly, making it prime real estate for early missile warning systems and constant communications relays.
And then there are the highly specialized orbits, like highly elliptical orbits. The classic example the sources give is the Molniya orbit.
Right, developed by the Soviets.
These trace a long, stretched-out oval shape. The satellite whips violently around the southern hemisphere, and then, as it reaches the furthest peak of its oval over the northern hemisphere, physics slows it down.
It seemingly just hangs in the sky over the high northern latitudes for hours at a time.
Which is just an ingenious workaround for communicating with forces near the North Pole. Because standard satellites parked over the equator simply can't reach up there due to the curvature of the Earth.
So physics and geography dictate the orbits. But this raises an important question. How does that physics translate into actual joint military operations?
Right.
That brings us to joint all-domain operations. The military recognizes that space is the ultimate connective tissue. It's the invisible web that makes unified action possible across land, sea, air, and cyberspace.
Joint Publication 314 lays out specific space mission areas. But instead of just listing them, let's look at how they weave together to support a modern warfighter. Take positioning, navigation, and timing.
which we all just think of as the global positioning system on our phones.
Right, exactly. But for the military, it is the absolute pulse of modern combat. When a pilot drops a precision-guided smart bomb, it relies on timing signals from orbit down to the nanosecond to hit a specific building.
And if an adversary takes out those timing signals?
That high-tech smart bomb becomes a dumb piece of gravity-fed iron, and the military is suddenly forced to fight like it's 1945.
Which is exactly why satellite communications is another critical mission area. Modern warfare is dispersed over massive geographic areas.
Right.
A commander in a bunker in the United States needs to talk to a small special operations unit in a remote mountainous region on the other side of the planet. They can't run a physical wire, and standard radios rely on line of sight.
So they bounce their signal off a satellite in orbit to bridge that global gap.
Exact.
Which naturally leads to intelligence, surveillance, and reconnaissance. Because if you can communicate globally, you also want to see globally.
Of course.
Satellites orbiting overhead provide access to denied regions where you can never safely fly an airplane. They gather high-resolution optical imagery, they penetrate clouds with radar data, and they vacuum up electronic signals, all without ever violating a nation's sovereign airspace.
But to protect all of these capabilities, the military relies on space domain awareness. And the doctrine makes it very clear that this is far more complex than just tracking floating space junk to prevent collisions.
It's not just a space traffic control system.
No, not at all. Space domain awareness means understanding the intent and the motives behind what an adversary is doing. If an adversary's satellite suddenly fires its thrusters and changes trajectory, space domain awareness isn't just noting the new location.
It's analyzing why it moved.
Exactly, determining what its sensors are now pointed at and predicting what terrestrial operations it might be getting ready to support.
So, if the United States military's entire force structure assumes continued access to these space-based services, like if they assume they'll always have precision navigation, global communications, and overhead imagery, that creates a massive vulnerability, doesn't it?
Oh, it's the ultimate Achilles heel. Adversaries know they cannot match the United States tank for tank or ship for ship.
But they don't have to.
No, they don't. If they can blind the satellites, if they can sever the air hose to those deep-sea divers we talked about, they can cripple the terrestrial force and level the playing field without ever fighting the United States directly on the ground.
Which brings us to the grim reality of the modern space domain. The doctrine describes it as contested, congested, and competitive. It isn't a peaceful vacuum. It's a bustling, highly tense environment.
Very tense.
So what does this all mean? How does the military posture itself against these daily threats?
They view it through a framework called the competition continuum.
Okay.
It's not a simple binary of peace or war anymore. It's a constant, simultaneous state of relationships divided into three categories: cooperation, adversarial competition below armed conflict, and armed conflict or war.
Got it. So in the cooperation phase, that's about building international partnerships and shared reliance?
Yes.
Like when the United States shares data with allies or operates multinational systems together, it actually acts as a massive deterrent. Because an adversary might want to jam a United States military satellite, but if that same system is routing commercial financial data for half of Europe...
An attack on that one system suddenly becomes an attack on the entire global economy.
Right. But underneath that cooperation, you have competition below armed conflict.
And this isn't theoretical. This is happening right now on a random Tuesday afternoon at a Space Command Center.
Really? Just daily?
Daily. It involves adversaries constantly probing defenses. They might maneuver a satellite suspiciously close to an American communications relay just to see how fast the United States notices and reacts.
Wow.
Or they might temporarily blind an optical sensor with a ground-based laser. It's a relentless game of geopolitical chess, constantly trying to gain a tactical or informational advantage without ever crossing the threshold into actual violence.
But if that deterrence fails, and somebody flips the board, we enter armed conflict and war. The ultimate goal here shifts rapidly to achieving space superiority.
Right, and the doctrine defines space superiority as having the degree of control that permits you freedom of access and action without prohibitive interference, while simultaneously denying that exact same freedom to your adversary.
And achieving that superiority requires aggressive action. It involves orbital warfare, which means physically maneuvering spacecraft to defend assets or attack enemy systems.
It also involves navigation warfare, where you are frantically working to protect your own positioning, navigation, and timing signals while actively jamming or spoofing the enemy's signals to throw their missiles off course.
Which forces a really uncomfortable realization.
What's that?
If a massive conflict breaks out down here on Earth, say, a naval battle in the Pacific or a major ground war in Europe, does that automatically mean a war in space is happening at the exact same time?
Absolutely. The two are permanently intertwined now. Space is simply too deeply integrated into terrestrial operations. Denying an adversary's lines of communication in space is now just as critical as bombing a bridge on the ground or blockading a shipping lane at sea. You simply cannot fight or win a modern war on Earth without fighting for control of the space domain hundreds of miles above it.
It's just a staggering shift in perspective.
Yeah.
We've traveled from the peaceful, almost utopian foundations of the 1967 Outer Space Treaty, where space was declared the province of all humankind.
Right.
We've traced how a simple cable bill dispute shaped domestic law, and how military policy evolved from passive exploration to recognizing space as a critical center of gravity. We've mapped out the physical realities of orbits and the vulnerable links between the ground and the stars, and we've unpacked the complex doctrine required to secure space superiority across a relentless continuum of competition.
But as comprehensive as these current doctrines are, if we connect this to the bigger picture, there's a frontier rapidly approaching that these sources warn we aren't fully prepared for.
What's that?
Well, we spent this entire deep dive talking about low Earth orbit and geosynchronous Earth orbit, but commercial industries and international rivals are already looking much further out to what the doctrine calls the cislunar regime.
Wait, you're talking about the vast expanse of space between the Earth and the Moon.
Precisely. And specifically, the doctrine points to the Lagrange points within that regime.
Lagrange points.
Yeah, these are highly unique, invisible gravitational parking spots where the pole of the Earth and the pole of the Moon balance out perfectly.
Oh, so you could park a satellite or a space station there,
Right.
and it requires almost no fuel to stay in place.
Exactly. And as the global focus shifts toward lunar exploration and mining the Moon for resources, these deep space gravitational parking spots are poised to become the next strategic choke points in human history.
Which leaves you with a deeply unsettling question to mull over. Will the optimistic, peaceful treaties written back in the 1960s hold up when modern nations are actively fighting for economic and military dominance near the surface of the Moon?
It's the multi-trillion-dollar question.
It really is. We want to thank you for joining us on this deep dive into the source material. Keep looking up and keep questioning how the invisible infrastructure above our heads continues to shape the world beneath our feet.